Right, this is a test from the series Note. So the test is based only on vectors. So this is a great opportunity for you to enhance your vector knowledge. I need to tell you about the importance of writing these tests, right? So we are covering just a subtopic each week. So you can revise the earlier stuff again. So this revising part is very important. In physics, like everything is like linked. So if you don't remember the previous stuff, well, then you are going to find things harder, right? Because in the classes, we are not going to revise everything, early stuff again and again. So having a good base on the earlier stuff is really important. So vectors is one of those. So vector is like the base of mechanics, right? So most of the mechanics terms are vector quantities. Those quantities are vector quantities. So you need to have that understanding of how to deal with vectors. So I think this is going to be great to enhance that and revise those stuff, right? Okay, so we'll move on to the first question. The option which contains one vector and scalar. So mainly there are two parts, scalars and vectors. So we know that scalars only has a magnitude. It have only a magnitude. Vector quantities has a direction as well, in addition to a magnitude. So vectors have both magnitude and a direction. But scalars only has a magnitude only, because when we are describing the scalars, only the magnitude matters there. Okay, magnitude means size of that physical quantity in simpler terms, right? So in this question we need the option which has a one vector and a one scalar. So this is a simple question, right? So the first one should be a vector. Right, in the first question, displacement, acceleration, both are vectors, right? When you think about power, speed, both are scalars there. Work, potential energy, those are energy related. So energy is always scalars. Energy only has a magnitude. It doesn't have a certain direction. Then when it comes to force and kinetic energy, so force is a vector, obviously. Force must have a direction, otherwise force is meaningless, right? Because when you apply force like this and when you apply force to this direction, it causes different results, even though the magnitude of the force is the same. So force must have a direction as well. So force is a vector. Then another one is kinetic energy. So all the types of energy are scalars, right? Any type of energy is a scalar. So the answer should be fourth one, vector and a scalar. Okay, second one, sum of vectors below is. Okay, so they have given a set of vectors 15, 14, 11, 14, 11, 12. So all these vectors are like parallel vectors, right? They are either to this side, to this direction, or to other direction. These vectors are not inclined vectors. So we can easily simplify something like this. You should know, in order to simplify two vectors or a bunch of vectors, their directions must be to the same direction. Otherwise you cannot do that, right? Okay, when you add these two, so I'll make everything to a one direction. So 15, I'll just keep it like that. 14, you can change the direction and put a minus here. Then it becomes minus 14, an arrow here. I'll just put a one arrow to all terms, right? 11, it is just plus 11 because it is already to this direction. Then this 14, you can flip that, put a minus there. 11, same direction. This is opposite, so flip that, put a minus there. It becomes minus 12. So I'll just add these plus terms. 22, 37, plus 37. Then you have to add all these negative terms. So this is 14, 14, 28, 12, 28 plus 12, actually minus 12, it is 40, right? To this direction. So when you simplify this, this becomes minus 3 to this direction. So if you want, you have to place the answer in a positive manner, right? Positive manner means as a positive number. So you can change, so you can flip the direction and make it a negative. So negative negative is going to be positive there. So you can flip the arrow and make the number a positive vector, right? Like that. So the sum of all these is to 3 to this side. So the answer should be fourth one there. Right, third one, find the magnitude of sum of forces below. So these are forces, so they are vectors, right? So we have given forces 4 Newton plus 3 Newton upwards. So these can be two forces acting on a one object, right? Or can at different places, so at the same place, it doesn't matter. So you have to make these forces according to one of the ways. So we have about like 2 or 3 methods in order to find resultant of two vectors, right? Resultant of two vectors. So in the previous question, those were like over to this side or to opposite side. So you can simply put a plus or minus and do a simplification. But when the vectors are to incline, they are inclined. Vectors are inclined, you cannot do those calculations simply. That's why you need to follow parallelogram law, triangle method, those stuff, right? You can make this as a parallelogram. I'll just describe this further. I'll explain two types to do this question. So according to the parallelogram, how do you make it a parallelogram? Keep 4 Newton here. Bring 3 Newton to there. So you need to form these vectors according to this. 4 Newton here. The thing about vectors is you can move the vector anywhere you want. But you have to move the vector parallel to the initial vector. You cannot change the direction. So without changing the direction or the magnitude, you can move like this. This is moved like this, parallel to the previous vector, right? So the vector is not damaged there. Same vector. 3 Newton here, same vector. So in order to make the parallelogram, according to the parallelogram, when you make two vectors starting from a one point, then if you complete the parallelogram, the diagonal of the parallelogram which goes through that point gives us the resultant. Actually, this parallelogram becomes a rectangle because these are like normal, perpendicular to each other. So this becomes a rectangle there. So just when it is a rectangle, it is easily you can find the length of this. So this, if this is 3, this also is 3. Then r squared equals, just apply Pythagoras, 3 squared plus 4 squared. So this is 25. So r is equal to 5 Newton, right? So that is parallelogram law. This simplification, I know everyone can do this, but I need to understand the difference of forming the parallelogram and the triangle method. So the parallelogram is done. So you have to place the vectors like this when it comes to parallelogram law. Then we have triangle method. What is that? So you have to form these vectors like this. Bring 4 newtons here, parallel to the initial vector. So it is not damaged, right? 4 newton here. Then the another vector, you have to make it a triangle. Where this vector ends, you have to start the another vector. So you can see that is to one side, right? So here you have 3 newton. So according to triangle method, when you have two sides showing vectors like this, the remaining side shows you the resultant. So that is parallelogram from here to here, right? Not from here to here, from start to the end. So in this method as well, you can find R. You can see it is the same as here, right? But the arrangement of those vectors is different when it comes to two methods. You have to clearly understand. So when you apply Pythagoras, you get the 5 newton. Okay. Sometimes using this method is easier. Sometimes you have to use triangle method. It depends on the question. So the answer here is 5 newton, obviously. Right. Fourth question. What is the resultant force of system below? Right. So we have given two forces, 8 newton, 6 newton, and the inclination is 120 newton, sorry, 120 degrees. So what they ask is the resultant of this system. So to find the resultant, we know this equation. Q squared plus 2pq cos theta. So P is one of these is P, one of these is Q. So P is 6 squared plus 8 squared plus 2 times 6 times 8 cos 120. Okay. So this is 36, 64. 36 plus 64, it is 100 plus 2 times 6 times 8 cos 120. If you remember the value of cos 120, it is not half, right? It is minus 1 over 2. The maths students clearly knows this value. There's a method, if you don't know the value as well, I'll explain that as well. So these two and these two cancels off. So this is 100, 6 times 48 minus 48. So this is 52. R squared is 52. So 52 means 4 times 13, right? So when you take the root from the both sides, 2 squared gets it to the outside, 2 inside remains 13. So this is the vector. So in the question, they haven't simplified that further. So it should be 2 root 13. Fourth answer. Fourth answer. Right? So when it comes, so they are only asking about actually the magnitude of the resultant force. They are not asking about angle. I mean, so the resultant could go like this. This is the resultant. They are not asking about this alpha. They are not asking that. They are only asking about resultant force. So, but in order to find this, you have to know this cos 120 is equal to minus 1 over 2. So if you don't know this, there's another method you can use. I'll explain that as well. We call this resolving method. So this is another way to do vector calculations. Okay, right. So I'll first get all the components to this side. So if I consider this to be the positive side, so there's 8 newton that side, directly you can put 8 there. Then what is this angle? This is 120, so this angle should be 60 degrees. Then you need to get a resolving. This is what you call resolving, right? 6 to the same side, 6 cos 60. But since it is to this direction, you can put a minus there. 6 cos 60. So when you simplify this, 6 times 1 over 2. So this is 5 minus 3, that is just, 8 minus 3, that is 5. So to this side, there's 5 Newton, x direction. Let's say x direction. Then to y direction. What do we have? 6. You can go either sine 60 or cos 30. We'll go sine 60. 6 sine 60. Sine 60 means root 3 over 2. So this becomes 3 root 3. 3 root 3. Now we have made this system into perpendicular components, right? Normal components. So y is to this direction, we have 3 root 3, and x is to other direction, that is 5. So we have made this whole thing, we have projected this whole thing into a rectangle. So once you get the rectangle, the diagonal of the rectangle gives us the magnitude and the direction as well, but we only need magnitude in this case. So r is what? 5 squared plus 3 root 3 squared, root of that. So 25, 9 times 3, 27. Again you get 52, right? 52 root, meaning the same answer, 2 root 13 Newton. So these are two methods you can use, right? So these resolutions, you should know that. So if there's any vector like this, let's say f, and if this angle is theta, to the same side it is always cos, f cos theta. To this side it is f cos theta. To normal direction it is f sin theta. So what you did is you resolved this whole system into x direction and y direction. Then you can create, any system can be reduced like this into a rectangle, right? Any vector system, it can have more than 2 vectors. So you know, when there are more than 2 vectors, you cannot use a parallelogram method, right? So you need to go for this method, vector resolution, that is, right? You just reduce the whole system into x and y components, right? So you get the same result there. So that is applicable for this resolution method, is applicable under any circumstance, right? Fifth one, what is the magnitude of resultant of following system accurate to 2 decimal points? Right, so we have given 7 Newton, 9 Newton, and here it is 45 degrees. So you can simply use parallelogram equation. R squared, Q squared, P squared, 2PQ cos theta. So 1 is 7 squared, 9 squared, plus 2, 7, 9 cos 45. 7 squared is 49, 81. This is let's say 63 times 2. Cos 45 is 1 over root 2. So 49 plus 81, 130, plus there's 2 here and there's a root 2. 2 means root 2 times root 2, right? So wait, you can cancel 1 root 2 there. Then 1 root 2 is remaining. Then 63 root 2. So 130 plus 63 root 2. Root 2, the value of root 2, typically you have to know the values of those numbers, right? Root 2 is 1.41, you know. So if you substitute, they are asking the accuracy up to 2 decimal points. So you need to substitute 2 decimal points, right? Otherwise you would get a wrong answer there. So this is r squared. Okay. Here you need to use logarithms in order to find the square root of this whole thing. In order to find the square root of this, you need to go for logarithms. Don't use calculators, right? Don't do dumb things like that. Use logarithms. The goal of this question is actually to make you use logarithms there in order to find logarithms. So you know how to do that, right? Just find the log of this number. Let's say you get something like this, then half it, then you get a number something like that, then convert it to anti-log. You have to practice doing this, okay? So then get the root of that. So the answer should be fourth one there. So that is 14.80 Newton. Don't use calculators, right? In the exam, you are not allowed to use calculators. You need to have practice doing questions by using logarithm. Right, sixth question. Two forces, 4 Newton and 3 Newton, are applied on an object. The maximum value of their resultant is. Okay, we have 4 Newton and 3 Newton applied on an object. So how can we find the maximum? So in order to have the maximum value, we can choose any angle. So it is obvious both forces should be to the same direction in order to create the maximum value. In all the other cases, you get a less value than the maximum. So you have to form both forces to the same side. Then you get the maximum. That is 4 plus 3, 7 Newton. Answer is third one. Seventh question. The magnitude of the resultant of two equal vectors is equal to f when these vectors are inclined at an angle of, right? So what they say is we have two vectors and the resultant of those vectors also is f. Resultant of also is f. What they ask is, when does this happen? In order for this to happen, what should be the inclination between initial vectors? Initial vectors means these two. You can think about this using a triangle method. Let's try that. I'll just draw this f like this. Another f like this. Can we have this to be equal to f? So it is obviously this is larger than f, right? So in this method you can't. You can draw like this, f, another one here. So this is head to tail method. So you know the triangle should be equilateral triangle, right? All the sides should be same. So this side f, another side f. The resultant also should be f. Resultant also should be f. So we have an equilateral triangle. This is the only case that suffices the requirement. So this is an equilateral triangle, so obviously this angle is 60 degrees. Then what is the inclination between this F and this F? In order to get the inclination, that theta, you need to form this starting from a 1 point. So you have to move this back again, right? So it is obvious this angle is 120. So here you have F, then another F like this. Then this angle is 120. You just have to move this side parallel to that, to here. Then this angle becomes 120, right? This 120. Then the resultant F goes like this. That is resultant. Then if you want, you can complete the parallelogram as well. So this is a geometrical method there. In the explanation sheet, you can download it below the video description. There's another method. I just used a parallelogram method. But in order to use that method, you need to know stuff like cos, negative cos values, right? So otherwise, in this way, you can figure out what should be the angle between those two vectors. So the answer should be second one, 120 degrees. Right. Question number 8. Resultant of the vector system below is, right? So we have a bunch of vectors arranged in a certain form. So what they're asking is resultant of this whole thing. So you can see there's like that. So using triangle method, there is polygon method, right? So polygon method is used to get the vectors. When you have more than two vectors, we have to use polygon methods. So according to polygon method, so when you arrange vectors in some way like this, but it should be another vector should start from end of the previous vector like this, right? To one side, right? It doesn't matter, it can go like this, doesn't matter, but it should go to one side like this. So let's say you couldn't complete the polygon. So there's a remaining side. So you used all the vectors in the system, but you cannot complete the polygon, right? So what does this mean? That remaining side to be completed should be the resultant vector. That is polygon method, right? Here as well you can use that. This is an easy question, right? So EF, FA, AB, BA. So it goes like this. What should be the resultant of all these? There are four vectors. It starts from E, ends from A. So instead of this whole thing, you can just put EA. Instead of this whole thing, you can put EA. Because that's the resultant of all those vectors. Then what is remaining is the vectors ED and DA. Those vectors also starts from E, ends from A. So that also creates another EA to this side. So EA plus EA. So the whole system can be reduced into two EAs, right? So that's just polygon method there. Sorry, not A here, this is C here, right? I think here it is A. Here it is C, right? So it should be EC. EC plus EC, 2EC, right? So that's the second answer. So for the ninth one as well, you have to follow the same method. You can clearly see one set of vectors starts from G and ends at F. Ends at F. Right? Starts from G, ends at F. So this is the starting point, this is the end point of all those vectors. So you can say this is the starting point, so the resultant should be from G to F. Then in the middle as well there's a part that also starts from G, ends from F. So this whole thing creates a GF to this side. Then this middle part also creates GF because it starts at G, ends at F. So from G to F there's another vector. So when you add those two, it becomes 2GF. Right, 10th question. X and Y vectors drawn starting from P, from point P as shown by the image. Consider the sentences below. So here we have two vectors, X and Y. So we can form those, they have already formed these two vectors on a parallelogram. So according to parallelogram law, when you have two vectors, resultant of those two vectors, or in other words, sum means SUM, sum, or the addition of those two vectors, or the resultant is shown by this diagonal. So this is just addition of those. Not the sum of, addition of magnitudes of those, right? It is just vector addition. So you have to use those parallelogram equations in order to find this length. But you can denote that like this. So sum of these two vectors is shown by this diagonal. So some students know this. Then the another diagonal. If you think about another diagonal, remember this, right? It will be useful. This diagonal shows us X minus Y. Got it? This diagonal shows us X plus Y. Another diagonal shows us the difference of those vectors. This shows us the sum of those vectors. Okay? Actually, we can prove this one. Let's say you need to find QS. X plus Y, you already know that, right? What I need to find is QS. Okay, QS you can find, just apply a R in between. So this becomes QR plus RS. So what is QR? You can make a parallel vector here, right? So if this also can be considered as X. So QR is just equal to X. Then we have RS, but the vector is to this side. Okay. Actually, vector is to this side. That is SR equals Y. You can make SR from S to R, it is Y. But here you have RS. So you have to flip this. Make it a minus, make it SR. Then just substitute this whole thing here. Instead of SR to this direction, you can put Y there. Right? So this direction, QS is XY. Okay? Or else you can just remember that if this diagonal shows the addition of those two vectors, other diagonal shows the difference or the change of those vectors. It will be useful to remember that, right? So the answer should be A and B, fourth one. Right? Question number 11. Resultant vector of the system is. So if you carefully observe this, then this also is an easy question, right? It's an easy question. So you just have to think about, so we are applying polygon method again. So I have to think about starting points and end points. So this set of vectors, it starts from A, ends at D. So this whole thing creates, instead of that whole thing, you can put a AD there. Then already there's a AD here as well. So that is another AD. Then instead of this system, that also starts from A, ends from D to a one direction, right? So that also forms AD. So we have 3 ADs. So the answer should be second one. 12th question. A particle P at rest is applied 4 coplanar forces as shown by the image. Then the particle, right? So initially the particle is at rest, right? Then those forces are applied. So the particle will move towards the resultant of all these forces. So you have to find the resultant of these forces. We can actually reduce this to XY Cartesian plane. So let's say this plane is Y and this plane is X. So you can separately find X and Y components. I'll just find X first. 5 cos 45. Then you have 10 cos 45, but it is to the other direction, so it is a minus 10 cos 45. Then there's 3 over root 2 to this side. It's already to the x direction, so you just have to add that. And we don't have a component from this because it is perpendicular to x direction. So let's simplify this. Cos 45 is 1 over root 2, 10 over root 2 plus 3 over root 2. So this is 5 plus 3, 8, minus 10, it is minus 2 over root 2. Okay. Then if you want, you can divide this by 2. 2 means root 2 times root 2, right? So 1 root 2 cancels off, you get minus root 2 as the x component. X component means to this direction I have reduced the system. Then you need to reduce the system to y direction. So it is, we'll start from here, 5 sine 45. So to y direction it is sine, right? You can go cos as well, but it is, let's say, sine. 5 sine 45. Then this is 10 sine 45. That also positive. Then we don't have a component from this because this is perpendicular to y, right? You can think it like 3 root 2 cos 90. Cos 90 is like 0, right? So we don't have component from this one. Then this vector is to opposite side, meaning you have to add it like a negative. Minus 15 over root 2, right? So when you add these two, 5 over root 2 plus 10 over root 2 minus 15 over root 2. So this is 15 over root 2 minus 15 over root 2. 0. See that? So here we don't have a y component, actually reduced to 0 there, to y direction. So the whole system only has a component, that is, this whole thing is reduced to this one, right? To this direction minus root 2 to this direction. Then you can flip the arrow and make it a positive. So this whole system is reduced to root 2 Newton to this direction. So that can be considered as negative x direction. So the object moves towards PS actually, as they have denoted, this is PS direction. The resultant of whole system is just this one, root 2 Newton. So the first one answer. Right, 13th question. Two velocities acting on a particle are acting on a particle. So let's say like this. So what does it mean to act in two velocities? It doesn't mean object goes to both directions, right? The object actually moves to the resultant of those two velocities. An object cannot move to both two directions, two different directions, right? Obviously the object moves to the resultant of those velocities. That is similar to forces, right? And similar to any type of vector actually. Then there's a sum of magnitudes of them. Let's say those are v1 and v2. Then the sum of those, it is not the vector sum, addition of vectors, but this is magnitudes, right? So magnitudes, when they say magnitudes can be added simply, but vectors simply cannot be added, right? So since they are talking about magnitudes, you can just add those two, and that becomes 15, they say. Then when you multiply those magnitudes, it is 56. Then they say a resultant velocity is as 13. So those are given, right? So what they ask is what is these two vectors, values of v1, v2, and inclination between those two. Let's say theta, that theta inclination. So you can so you have two simultaneous equations. So you know when you can do the simplification as well, but this simplification is going to be a bit hard because you probably would get even a quadratic equation as well. Since this is a MCQ, you have to be smart about it, right? When you get answers there, somehow what you need is to get the answer, correct answer. So they don't give marks for how much you do the simplifications, right? You just have to get the answer there. So choose the answer which tally both these cases. First think about addition. When you get first answer, you get 8 and 7. So when you add 8 and 7, obviously you get 15. So first one can be an answer. Second one also can be, because 10 plus 5, 15. Third one, it cannot be, right? So you can cut that one. 4.5 and 3.5, it is not 15. So this is another method, right? This is very important, another method when you get MCQs. So you can eliminate all the wrong ones. You might not have a method. That method to get that answer won't be even in the syllabus, right? But they give questions like that in the exam. But the remaining answers, obviously according to the syllabus, all those answers, like 4 answers, are wrong. Obviously you can figure out that those 4 are wrong, but you don't know how to get the correct answer using what you know from the syllabus. But since what is the logic there? They expect you to follow. Even though you cannot get the answer, you can get rid of all the other 4 answers, right? So they are checking out the knowledge to whether you know how to get rid of the wrong ones. Then automatically you get the correct ones. Then you have to assume the remaining one should be the correct one, right? There are like not many questions, but Probably you might get a question, one or two questions in a paper like that. So here we are eliminating wrong ones, obviously wrong ones. So from addition, that is all you can do. Then we'll think about this one. Which ones provides 56? First one provides, second one does not. 10 and 5, that is 50, right? Not 56. So eliminate second one. You can eliminate fourth one. Then only two answers remaining is 1 and 5, right? 1 and 5. So fifth one also, it is 8 and 7, right? So it is obvious V1 should be 8, V2 should be 7. It can be either the other way as well, right? Doesn't matter actually. V2 can be 7, it doesn't matter. So we know the magnitudes of these without even solving, right? But in order to find angle, you need to do a simple calculation there. They have given the resultant 13. So use equation in the parallelogram law. So r squared is given as 13 squared. Q is can be 8 squared, 7 squared. 2p is 7, 8 cos theta. So when you simplify this, you can find cos theta. So 13 squared is 169, 64, 49. This is 56 times 2 cos theta. So this is 169. 64 plus 49 is 13, 12, 6, 2, 4. 6, 4, right? 46 or not? So here 64 plus 49, 3, 11, 169. 169 minus 113. So you get 6, 5, 56 equals 2 times 56 cos theta. So 56 cancels off. So you get 1 over 2. So cos theta is equal to 1 over 2. 1 over 2 means cos 60, right? So theta should be 60 degrees. So that should be the inclination there. So this theta is 60 degrees. Got it? So the answer should be fifth one, and you can eliminate first one. 14th, correct illustration that shows resultant of two vectors 8 and 6 Newton. So like 8 and 6 Newton, the inclination between them is, when you observe these answers, inclination is 90 degrees, right? So when you have 6 and 8 with 90 degree inclination, what should be the resultant? You can simply apply Pythagoras and find that out. 64, 36, 100. So resultant is 10. So just eliminate answers without a 10, right? So you can eliminate first and second answers. So the answer should be 3, 4 or 5. The only answer that matches with the triangle method is the third one, right? So what is the triangle method? When you have two vectors like this, one to this direction and another starts from the end of the previous one, 6 Newton. From the start to the end, there's the resultant, which is 10 here, not 14 Newton, right? It is 10 Newton. You have to geometrically find that. So the only thing that matches with the correct triangle method is this sketch, which is third one. Right, 15th question. A system of coplanar forces drawn to scale are acting on an object or vector that shows the resultant force mostly can be. So this is an exam question. These are drawn to scale. So whenever they say drawn to scale, you can actually, if you cannot clearly see just by looking at that, you can place your ruler and measure the lengths of each vectors, right? So they are thinking about, they are trying to get your, the vector can be represented graphically. So in this question, what they check is whether you have done those graphical representations of vectors, right? Especially in practicals, the practical that you do use in police and white paper, board, those stuff. In that practical, you need to draw a parallelogram based on those vectors, right? So drawn to scale, you can actually measure these. So actually, if you cannot clearly see, if you don't see a clear idea to reduce the system, the first thing is you need to reduce the system. So if you measure this length is and this length, they are the same length. So you can get rid of these two. Opposite, they just cancels off, right? Those two vectors. Okay. Then this vector and there's another vector this side. You can get rid of this. When you can reduce that length from here, then this vector could decrease like this, somewhere here. You can do the same for this one. This part can be reduced from here because it's the opposite. So this reduced to here. Okay. Then this is removed because you reduce this much from here. Then another one, this opposite part, you can reduce it from here. Okay. Then you have C here and B here. So the resultant of these two vectors are from right between here. Then instead of those two, you can have this. This one and this vector, it needs to have a resultant which goes through around C. They are asking about approximately what is the most possible answer. So the system can reduce to one single force, which becomes the resultant of the whole system. So any vector system can be reduced to a single vector, which we call the resultant vector.